Transform repositories into DevOps-ready pipelines. Analyze repositories, generate Docker files and CI/CD workflows, validate configurations and monitor deployments, all through intelligent DevOps. ShipIQ is our intelligent DevOps automation platform designed to simplify DevOps adoption by automatically analyzing repositories, generating missing DevOps artifacts, validating configurations, and tracking deployments through one integrated workflow. The platform follows a structured repository automation pipeline consisting of 4 stages: analyze, generate, validate, and track. Repositories are first scanned to detect the technology stack and missing DevOps components. Based on that analysis, required artifacts are generated, validated, and then monitored through deployment tracking. ShipIQ's automation engine follows a 5-step workflow: repository analysis, gap detection, artifact generation, validation with pull request integration, and deployment tracking. This creates an end-to-end automation pipeline from source code to deployment visibility. The platform combines repository analysis, template-based generations, validation checks, and deployment tracking into one unified DevOps automation system. Once connected, repositories can be transformed into production-ready systems with minimal manual setup. Users connect securely through GitHub app authentication without using personal access tokens. After authentication, the dashboard provides an organizational overview of DevOps maturity and automation readiness across repositories. It displays repository counts, maturity scores, repositories requiring attention, and overall platform health. Here, repositories with missing DevOps components are surfaced for remediation. Coverage and maturity levels are summarized across all connected repositories. Let's go on the repository tab, and here you can see all the repositories access to our platform by the client. So let's go on a specific repository, and here you can see at repository level, ShipIQ provides DevOps intelligence for individual product. Repositories pipeline covers scanning, secret configuration, artifact generation, and deployment to GitHub. The system detects missing DevOps components such as Docker files, CI/CD workflows, and test configurations. In this repository, Docker, CI/CD, and test scaffolding are currently absent. If you run a production scan, then all these missing documents are absent. So here you can see that it was last scanned right before a few minutes ago, and this is the current health of the repository. The platform also verifies required environment configurations such as Mongo URI, JWT secrets, port, node env, etc. All these are the environment variables which are already configured and input by me. Using intelligent autofix, the platform can generate missing DevOps components automatically. Here, the system generates Docker configurations, CI/CD workflows, test scaffolds, and deployment files using predefined templates. This converts a traditional repository into a DevOps-ready project. Once the artifacts are generated, orchestration is handled through the automation workflow in n8n, which would be shown in the chapter 2. This workflow acts as the automation engine connecting repository analysis, generation, validation, GitHub integration, and deployment status updates. The workflow starts when repository data is received through a webhook from the platform. Repository metadata, scan results, and gap reports are normalized into a structured execution content. A rule engine evaluates the scan results and determines which DevOps artifacts need to be generated, such as Docker files, CI/CD workflows, or test scaffolding. An execution plan is dynamically created and routed to the appropriate generators. Based on detected gaps, specialized generators produce the required DevOps artifacts using predefined templates. Docker file generation, CI/CD workflow generation, test scaffold generation. Each generator produces validated configuration files rather than relying on unconstrained generation. Generation artifacts are merged, converted into a commit payload, split into repository files, and committed automatically into a generated GitHub branch. Branch creation and commits are fully automated as part of the workflow. After code generation completes, the workflow sends a completion payload back to the backend, updating dashboard state and triggering the next deployment stage. The workflow also handles automated branch creation before code commits are pushed. So, the n8n workflow serves as the orchestration layer that connects repository analysis, intelligent decisions, artifact generations, GitHub integration, and status feedback. Once code is committed, execution continues through GitHub Actions. Once the workflow commits generated artifacts into the repository, the execution now moves to GitHub Actions where the generated CI/CD pipeline is validated. This is the generated GitHub Actions pipeline responsible for validating the repository to staged Docker-based CI checks. This pipeline runs on GitHub hosted runners and executes deterministic validation stages instrumented using ShipIQ stage annotations. So in the annotation part you can see the pipeline first verifies project structure by checking the required files such as package configuration. Next, environment variables are validated using secure GitHub environments before build execution. Missing secrets can be detected before deployment failure occurs. Dependencies are installed and validated as part of automated build preparation. Tests are executed during pipeline, providing an additional validation layer. The workflow then performs Docker image generation to validate containerization readiness. A runtime smoke test launches the container, waits for startup, and verifies the application is running successfully. These container logs are scanned for fatal startup errors such as runtime exceptions or failed initialization. Each stage emits ShipIQ annotations which enable deterministic failure classification in the backend. If any stage fails, for example, environment validation, dependency installation, text execution, or Docker startup, the failed stage is classified and surfaced back in the platform dashboard. Once all validation stages are passed successfully, the repository is considered deployment ready. This completes the end-to-end workflow from repository analysis and artifact generation to orchestration and CI/CD execution. Unlike a conventional CI pipeline, this workflow performs staged deployment validation with deterministic failure signaling. ShipIQ transforms repositories into DevOps ready systems by combining intelligent generation, orchestration, and deterministic deployment validation. Thank you.